All right, so I am going to talk to you guys about Fresnel lenses, and then we are going to do a cool demo where we get to go outside and melt some rocks. So Fresnel lenses are basically, they're like regular lenses, but they're cut up into so that they are designed to be smaller. So this is originally done because large magnifying lenses are really hard to manufacture because they have to be really thick at the middle, and then they taper at the edges, which makes them like really heavy, which makes it hard to mount and like hard to hold up and stabilize. So Fresnel lenses were developed to account for this error. So basically, a Fresnel lens is flat on one side and it's rigid on the other, so that it's like cut circles that angle in, which I'll talk about a little bit more later on. This reduces the weight but has the same magnifying effect. As you can see here, here's a Fresnel lens, a large one used in lighthouse, which is their primary usage. But yeah, so the basic idea behind a Fresnel lens is that you take a big plastic magnifying glass lens and slice it into a bunch of concentric rings. So concentric rings around the front, like the rings of a tree. And each ring is slightly thinner than the next and focuses the light towards the center. And then you now take each ring and modify it so it's flat on one side and make it the same thickness as the others. So as you can see here, the thicknesses are all pretty similar. To retain the ring's ability to focus the light toward the center, each angle will be different. So there's mathematical equations that can calculate how different they are. And now if you stack the rings all back together like so, you have what they call a Fresnel lens. You can make the lens extremely large if you like, which replicates a large magnifying lens. And they're often used as solar concentrators. So that would be the opposite of what this video shows. They would focus the light in from a source. This example here is how it's used in a lighthouse. So there's a light source, and then that light source is collimated by this Fresnel lens so that it can go for many, many distances. So the first Fresnel lens was used in 1823 in the Cronin lighthouse, and its light could be seen for more than 20 miles out. And Fresnel's invention increased the luminosity of the lighthouse lamp by a factor of 4, and thus his system is still in use in many lighthouses around the world. The only disadvantage to Fresnel lenses is they have pretty poor image quality, or worse image quality than traditional lenses. One of the aberrations that we see in Fresnel lenses are spherical aberrations. This is because light rays traveling through a Fresnel lens at different angles will come to a slightly different focus point. So yeah, so the slightly different focus point, which gives a blurred image. You can get quite a bit of distortion because the surface of a Fresnel lens is discontinuous. Or you can also get distortion because it's this discontinuous lens, unlike the smooth curved lens. You also have chromatic aberration because of the different angles of the segments. Different colors have different wavelengths, so they're going to refract differently, which will give you unwanted color fringes. You can see that here. And although it's possible to adjust the angle of the steps in the Fresnel lens to minimize aberrations, the typical applications of Fresnel lenses don't really need high optical performance. You would use something else if you needed that. So here's a pretty good depiction of that lighthouse application. So basically, what I talked about earlier is they have this light source here that hits these Fresnel edges and then collimates out. in theory, you could make a lighthouse beam with just an ordinary glass lens, but the Fresnel lenses tend to be lighter and are more efficient, basically. And since you don't really need good optical quality, that's not important. Basically, lighthouses use hollow, lightweight Fresnel lenses, which have this very distinct step shape that you can see here. And the name Fresnel actually comes from Augustin Jean Fresnel, the French physicist who pioneered them in the early 19th century. Yeah. So here's the actual Fresnel lens that you would see in a lighthouse, and then there's a nice lighthouse accompanying it. So now we're gonna go outside, or Hillary and I are gonna go outside and use a Fresnel lens to focus light, so opposite of the lighthouse application, and we'll focus it as a magnifier. And so this involves the finding the focal point of the lens. So and at that focal point is the point that will melt, because the energy is about 500 watts for the 0.5 meter lens that we'll be using. And so here are some typical temperatures it takes to melt certain materials. So aluminum's quite high up there at 600 C, and then you have brass and copper, and then concrete's all the way up there at 1000 Celsius, which is really high. And then steel and lava rocks as well. I want to remind, if in case, like there's young viewers out there, remind you to be safe when, don't do this at home. What we're going to be doing is we're going to use safety glasses, and we're going to be really careful, and remember to never look directly into the sun because that can damage your eyes. But yeah, so that's that. Yeah, so now we'll show you the actual melting of the rocks.
So right here, oh gosh, I cannot see the screen at all, but I have our big Fresnel lens that we are going to use to magnify or get light from the sun. And you said it's got to be perpendicular to the sun, right? And that will focus down so that we can find a focal point in front of the lens that will heat up a lot. I think 500 watts is what you said? 50 watts? Is that right?
Yeah, it was like 500.
Yeah, 500. Don't know which side is the. I think this is the. Yeah, so this is the step side.
So you can hear by touching it, smooth side with the ridges on it.
Yeah.
Right, so we want ridges toward the sun.
Okay.
So here's our rock. Right,
where's that rock? Oh, there we go. Okay.
So yeah,
That's
ridges toward the sun. So a rock will go there. Let me point you guys down. There we go. So we all have our safety goggles on. You helping her out, Matt?
Yeah.
You guys need to go higher. There we go. So you can see how they're creating a point. Look at that, instantaneous.
Wow.
We are melting rocks. Hopefully you guys can see that. Oh, I shouldn't look.
Yeah, I don't know if the video can see it or not.
Wow. All right, that's probably good.
Okay.
So now that we've done this, you don't want to touch it. It is super, super hot, but we will, after we do our next one, we'll take you down close so you can see that it actually turns it into obsidian rock. So what we're going to do now, so you guys can see, we've got a penny here. So pennies are made up of copper and mostly zinc. So we'll put that down, we'll kick our rock out of the way. We'll do the same thing all over again. Now this goes really quick. Once you get the right spot, you can see it instantaneous. We're vaporizing a penny.
Were you on the right spot?
Yeah, you guys are pretty, yeah, there it goes.
There it is.
Gone. All right, pull it away or we're gonna burn the pavement. So there's that. So I can like see for real. So now I'll go down and I'll show you guys, because I don't want to pick it up yet. Can I even see? Can you even see? Yep, there we go. So that's what we did to the rock. And that is how we use a Fresnel lens to melt rocks and burn disintegrate pennies.
Yeah.
Anything else you want to say?
No, I think that's it. That was really cool.
All right.
Don't try this at home.
Oh, you want to see the penny too? All right, we can do the penny. Can't see what they can see. Where's it? This one even has a hole directly in the middle of it. But if you keep going long enough, it will disintegrate the penny completely. We just don't like to do that because it leaves burn marks on the pavement when we let it go for too long.